Good morning. I am welcoming back you in the practical 1 graph of some Cartesian curves. In the last practical, I have given you to plot a graph of f of x is equals to sin x on 0 to 2 pi. As all of you are aware with these things that we can plot curves in Excel. I have opened this Excel file and I am going to plot my curves in this Excel. So I don't have to evaluate the sin x values in my required range. Okay. So here I am writing values of x and here I am writing values of sin x. So as I was given you so that you can write values in either way. Let me start with this way: 0, 0 0.5, 1, 1.5, 2, 2.5, 3. Let me start with the initial, that is 1, 2, 3, 4, 5, 6, and final value is 2 pi. So I am writing here 2 star pi, and in this way it will give you approximate value of 2 pi. Now here I am giving a formula, that is sine of this number. To make you more visualizable, I am making this zoom so you can see that this is giving you answers of sine. And here it is saying that minus 2.5 e minus 16, that says that minus 2.5 times 10 raised to minus 16 means approximately 0. Now I want to plot the graph of this. So here I can go to the insert and then recommended charts. It will show you the approximate that sine curve. Say it to OK. It will give you the graph of the curve. You can give the title here. Sine x. Oh, sorry, what happened? Sine x. So it is the graph of the sine, but it is approximate. See, it is tuck, 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 and so on. So it is not sine's curve, but you know that it is approximate. Now I am doing the similar idea with much more points here. That is 0, 0 0.5, 1, 1.5, 2, and so on. And I am continuing, means you know that you can have a drag and drop option in Excel. Here somewhere it is 2 pi, so I am writing here it is 2 star pi and removing this entries. Now for this I am drawing the graph. Again go to the insert and then recommended charts. This is the approximate uh, sine x on 0 to pi, 0 to 2 pi. See the difference between this graph and this graph. It is, this was not proper close approximate, but this is much more approximate to the original graph. You can take further more best approximation. Let me do that again. I can go for 0 0.1, 0 0.2, 0 0.3, and so on. I am dragging this up to 6. It is reached 6.1, 6.2, and now I am writing that 2 star pi, and I am dragging this also. Okay, now I am selecting this region and again going to the insert and recommended charts. Okay, so it itself says that it is having more points and more approximation than previous. See here again it was not. If you will go to the zoom, see it is not looking smooth here this point. Similarly, it is not looking smooth here also. But you go to the graph we have reached, means obtained in the second part, it is looking much more smooth. It is having more points, it is also visible, and it is smooth also. So this is not recommended to draw in our journal, but in journal you can go for at least this much smooth region. Okay. Also, I have given you that you can go for the values like 0, pi by 6, and so on. So let me do that also in this. So instead of this, I am just writing these values, that is 0, pi by 6, then pi by 4, sorry, pi by 4, then pi by 3, then pi by 2, then I am removing this point so you can see. Now I am introducing pi by 2, then continue this fashion. Okay, you know points for which you can plot the points. Oh, sorry, it has not continued, it has just copy pasted it. Let me remove it. Then you can go for pi and then 3 pi by 2, 3 pi by 2, then 2 pi. I have skipped the points, but you can continue that, and you will see that it is also some approximation of the graph. Okay, but uh, doing this is much better in the journal, so we will go for this. So I am stopping here. This session means draw the graph of the sin x. I am giving you one more exercise, that problem number 3. Plot the graph of fx is equals to x from -3 to 3. F of x is equals to e raised to x. Okay, so plot the graph of e raised to x. You can take points as you want, but look, the graph should be looking proper. So I'm stopping here. Thank you.